This is Math 2, Unit 13, Section 1, Area, Arc Length, Circumference, and Sectors and Circles. So first we're going to start off with area and circumference in a circle. The area of a circle is the shaded region. So if I were to talk about how much area would be in a carpet, a circular carpet, it would be how much is the surface taking up. And area of a circle formula is pi times the radius squared. The circumference is talking about the outside edge. So if you were to take a string along the edge of that carpet, how long would the string be? We could also say that that's the perimeter of the circle. So circumference, there are two different formulas that you could use. We most use 2 times pi times the radius, but you could also say the circumference equals the diameter times the radius. The diameter times pi. And the reason for that is because the diameter is equal to twice the size of the radius, so 2r is really equal to d, which is the diameter. Either formula here is fine. If you are ever needing any of your formulas, please make sure you look on your geometry formulas reference sheet, and those formulas are listed here. So we're just going to start off with number 1, doing some examples. So number 1, 12 meters is my radius because it starts at the center and ends on the circle. So I'm doing the area formula, and I want to find the circumference of this circle. So starting with area, which is pi times the radius squared, I plug in 12 for my radius, and 12 squared is 144. So my area is equal to 144 pi, and my units are 12 meters times 12 meters. Area is measured in meters squared. Okay, if you wanted to find the exact answer or the approximated answer to the nearest decimal place, you would multiply 144 times pi. But in this case, you are welcome to leave it in terms of pi as long as you have pi written in your answer. The circumference is 2 times the radius times pi, or 2 times pi times the radius. Either way is fine. But twice the size of our radius of 12. Sorry, let's write the formula first. Always write out your formula. So 2 pi r would be 2 times your radius of 12 times pi. Now I can move the place of the radius in pi because multiplication is commutative, so it could be switched around. And that gives me 24 pi. So my circumference equals 24 pi, and circumference is a distance around the circle. So just like perimeter, our distance is measured in the first degree, so just meters. Okay, number 2. Number 2 gives me the diameter. So I need, in order to find the area, I need the radius. So what I have to do is take the diameter, which is 18, and divide by 2 to get the radius, which gives me 9. So my area is equal to pi times 9 squared, which means my answer is 81 pi inches squared. The circumference is 2 pi r, But in this case, you have the diameter, so you could use diameter times pi. And my diameter is 18, so my answer is 18 pi inches. Okay, we're going to do number 4 together, and you can go back and do number 3 on your own. So right now I have half of a circle, which we call a semicircle. Which means I can find the same, I can solve for area and circumference the same way, but at the end, my area part, I'm going to divide by 2 because it's like half a circle here. My circumference part, I'm also going to divide by 2, but I'll have to take into account this side at the end. So we'll see what that looks like after we do area. So the area of a circle would be pi r squared. My radius here would be 44 divided by 2, which is 22. So the area of the full circle is pi times 22 squared. You can do that on the calculator. 22 times 22 to 484. So the area of one full circle is 484 pi. And we'll have inches squared in a moment, but first let's go ahead and calculate for the semicircle, which is half of that full circle. So if I'm doing just the semicircle, you see how I drew in half a circle here instead of a full circle? That's not a 0, by the way. That is a circle. So I'm showing you that we're taking the area of a circle, and then I'm going to cut it in half for the semicircle. So if you take 484 and divide by 2, you get 242 pi. And now we can write our units, which is inches squared. That's our area of our semicircle. We're going to also do circumference. The circumference of the full circle is what we need to solve for first. So that's why I'm drawing a little circle next to my C for circumference. I have my diameter, so I'm going to use that formula, diameter times pi. So the diameter is 44, so this is 44 pi. Now remember, the circumference is the distance around the outside of the circle. So if I want to find half of it, it's going to look like this, and the bottom's not completed. So I know half of it is half of 44 pi, which is 22 pi. But then I also need to add the segment along the edge. So all around here is 22 pi. But I also need this edge here, so I add 44 to that, because that length is 44. Now that length is not 44 pi, so these are not like terms. So we'll leave our answer in terms of pi, and you combine like terms, but these two things are not like terms, so I just leave it as 22 pi plus 44. Moving down to arc length. An arc length is saying if you took a piece of string and laid it along this portion of the arc, how long would the string be? Your answers will not be in degrees here. A length has to be a distance, like meters or inches or feet or something like that. So if I'm talking about arc length, I want to find the length around the entire circle. What's the length around the entire circle called? Well, the distance around the whole circle, you should have said, is circumference. Well, like up here, distance around the entire circle is circumference. So if I want to find the distance around part of the circle, I need to know how much of the circle I'm dealing with. This one is 68 degrees. How much of the circle is 68 degrees? Well, we're really not sure. But if I talk about an example right here, and I said this angle is 90 degrees, well, we know 90 degrees fits into a circle 4 times because a full circle is 360 degrees around. So 90 out of 360 would be 1/4 of the circle. So I know that this length of this piece of my circumference is 1/4 of the entire circumference, because that could fit around 4 times. I could even section this off into 4 pieces, and you have 1, 2, 3, 4 of that length. So 1/4 of the circumference would give you the length of that one section. But we can just use the formula where x is the degree measure of the arc. So in this case, my degree measure of the arc was 90 degrees. C is the circumference. We're going to talk about that in a second, because we're going to take 1/4 of the circumference. But you need to take how many degrees you have out of the total, which is a total in a circle in degrees is 360, and then multiply by the circumference. So for number 5, I'm going to find the circumference first and then multiply it by this fraction. Please make sure you reduce your fractions. So we have circumference is equal to either 2 pi r, or diameter times pi. Let's talk about EB here. EB is 15 centimeters. That is a radius, so I'm going to use 2 pi r to find my circumference of the circle. So twice the amount of the radius is twice 15, which would be 30 pi. So that's the distance around the entire circle. So 30 pi is all the way around, but I want to know how much of the circle is this piece. Well, it would be 68 out of a total of how many degrees? So 68 degrees out of a total of 360 degrees will give us our fraction. And then we're going to multiply it by our circumference, which is 30 pi. Okay, so 60 over 300, I'm sorry, 68 over 360 is, they're both divisible by 4, so we could divide both of those, and you get 17 over 90 times 30 pi. But I can reduce these as well. So when we multiply a fraction by a number that's not a fraction, we can put that number over 1 and multiply straight across. And we're going to be able to reduce more. You can also cross-reduce. So if they're diagonal from each other, these two numbers are both divisible by 30. 30 divided by 30 is 1. 90 divided by 30 is 3. So then when I multiply straight across, my answer is 17 times 1 pi, which is 17 pi, and 3 times 1, which is 3. So 17 pi over 3, or 17 over 3 times pi, either way is fine. But that's the answer to number 5. 17 pi over 3. Okay, let's try that again. Number 6. If NR is 8 feet, then that is a radius. 8 feet is a radius because NR starts at the center and ends on the circle. Find the length of NMP. NMP is all the way around here. So, I know a few things. First of all, NQ is a diameter. So that means NMQ is a semicircle, or halfway around the circle. So I can find halfway around the circle and then add this piece here, or I can find the entire way around the circle and subtract this piece away. I'm just going to find the pieces that we know and add them together. But first of all, let's figure out the degrees of each of these so that I know my entire degree around the circle. So 162 is just the arc from M to Q. So I need to find these other pieces. If this is a semicircle, N, M, Q is a semicircle, then I can do 180 and subtract 162 to find NM. And that gives me 18 degrees. So this is 18 degrees, and then by vertical angles, this section will also be 18 degrees. So if I add all three of those up, I know what to put over 360. So 180, or you can do 162 plus 18 plus 18, which will give you 180 plus 18, which is 198. 198 out of 360, and you're going to multiply that by your circumference. And we know the circumference is 2 pi r. So times 2 pi, and my radius is 8. So we want to multiply these numbers together, and you can cross-reduce once you multiply your circumference together. So I can get 16 pi. Well, 360 is not divisible by 16, but it is divisible by 4. So if I put 16 over 1, these are both divisible by 4. So 16 divided by 4 is 4. 360 divided by 4 is 90. And then I also want to see, you can keep reducing. If 198 and 90 have things in common, you can reduce there, and they do. They're both even. So if I divide by 2, I get 45. 198 divided by 2 is 99. I can continue to reduce because those are both divisible by 9. That divided by 9 is 11. This divided by 9 is 5. But I'm starting to lose or have a lot of things I'm crossing out and repeating. So it might be best to just start and multiply straight across and then reduce your fraction. So what I'm going to do right now is show you on your calculator how to multiply these together and get the fraction answer. And we'll check to see if our answer matches what we have up here. So first let's multiply 11 straight across times 4 pi. So that's 44 pi. And 5 times 1 is 5. So we want to check to see if that answer is correct. My original things I was multiplying together, we multiply these two numerators together, so 198 times 16. Don't worry about the pi until the end, because we'll leave it in terms of pi in our answer. We get 3168. That's a really big number. So let's go ahead and divide by our denominator. 360 times 1 was my original denominator. And you get this fraction. This decimal. If you need to write your answer in terms of a fraction, which most cases you do, then your calculator can actually do that for you. So on this calculator, I'm going to go second and see where there's the F and the D. You're going to have to find the F and the D on your calculator. That just means fraction to decimal or decimal to fraction. So I can push that button and it changes my fraction into a decimal. Remember, I never multiplied this by pi. So don't forget, if you're simplifying, that you will still have pi in your numerator for your answer. And then when we want to talk about what my units are, I forgot to write my units on this last one as well, so we'll want to write that. Arc length is a portion of your circumference around the circle. It's not the entire circumference, but it's a piece. So I'm saying if I lay a string here, how long is the string? Well, it's a portion of the entire distance around, so that's in inches. I'm not filling in the area, so it's not squared. It's just a distance. So this one would also be in inches. Go ahead and solve 7 and 8 on your own. You can also solve number 3 on your own. You need to check your answer. You can come up and check your answer after the end of notes. For now, go ahead and go to the back side. We have one more piece of information that we're learning about. A sector is talking about area, but it's only the area of one piece of the circle. So this will be like, what's the area of this piece, the slice of the pizza or something like that. It's a portion of the entire area. Okay, so we're going to talk about, we're going to talk about the formula that the area of a sector is a portion of the entire area you can write a section of a circle bounded by a central angle and its intercepted arc. So this has to be a central angle, so the vertex is on the center. And the formula for that is going to be whatever your degree is for x out of the full degree of the circle, which is 360, times pi r squared, where r is equal to your radius. And this is just the area formula of a circle, so that's how we find that. So for number 12, we're going to do the same thing we did with arc length, but we're going to find a portion or a fraction of the area instead of a fraction of the circumference. So my angle is 120 out of 360. And when we have nice angles like that reduce to fractions, we probably just want to reduce them before we go on. But we're also going to multiply that by pi times my radius. My radius is PQ, which is 22 centimeters. My radius should be squared. So let's just simplify this fraction first to make everything a lot easier. So we're going to take 1/3 and multiply it by 22 squared, and from the other side we already did 22 squared is 484 times pi. So 484 times 1/3, we put 484 over 1. 1/3 times 484 over pi, you multiply straight across, and we get the area of that sector is 484 pi over 3, and its area, so we're in centimeters squared. Okay, let's try number 10. This section that's shaded, we don't know the degree of, but we know the degrees of an entire circle is 360. So I can find that degree by subtracting that other angle, 120. You get 240 degrees. So this time I have 240 out of 360. Well, this one was 120. If you reduce this fraction, this is 1/3 of the circle. 240 is twice of 120, so this is going to be 2/3 of the circle. And you can reduce those fractions. These are both divisible by 120. 360 divided by 120 is 3. 240 divided by 120 is 2. But we're going to multiply that by pi r squared. And in this case, my radius is GH, which is 13. So times 13 squared and pi. Usually I've been putting the 13 right here, so let's go ahead and do that. Plug in your 13 for R right there. And 13 squared, if you're ever not sure about your perfect squares, they are on the back wall. 13 squared is 169. And then we can multiply straight across as long as we put this over 1. So 169, or you can cross reduce as well. Are these two both divisible by 3? No, 169 is not divisible by 3, only divisible by 13. So I get 169 times 2, which is 338. We still have pi in my numerator. And then 3 times 1 is 3. This is area, so we're talking about yards squared. Okay, so you can do 11 and 12 on your own. We're going to do 13 and 14 together. 13, you're going to have to find one sector and then double it to find the other sector, or you can add those two angles together and do your fraction that way. So if I add, since these are the same angle, they're vertical angles, that would be 226. So I don't know if you can see that, but 113 plus 113 is 226 out of 360. And then our pi r squared gives me pi times, well, be very careful because xy is your diameter. How do we find the radius if we know the diameter? We have to take 30 and divide by 2. So that gives me 15. Pi r squared is pi 15 squared. Okay, so let's see if we can reduce 226 and 360. They're at least both divisible by 2. But if I do it on my calculator, yep, that's it. They're only divisible by 2. So this reduces to 113 out of 180. And 15 squared is 225. So times 225 pi. I can put that over 1 and multiply straight across. I can also cross reduce here. These are both divisible by 5. So let's go ahead and do that so I don't get such big numbers. If I divide by 5, I get 45 and 36. Okay, so then that means they're both divisible by 45. So instead of dividing by 5, let's divide by 45. 225 divided by 45 is 5. 180 divided by 45 is 4. But remember, if you want to plug it in on your calculator, you do 113 times 225 divided by 180 and change the decimal to a fraction, which should get you 565 times pi over 4 times 1, which is 4. And I'm going to show you how to do that on your calculator again, just in case you forgot. So we're going to do 113 times 225. That's my numerator. I'm going to divide by my denominator, which is 180 times 1, so divide by 180. Gives me a decimal, and you're going to do second and find that fraction to decimal button, and that gives you 565 over 4. So you don't have to cross reduce, the calculator will reduce for you. We're talking about area, so that's a shaded region, which is squared, feet squared. And then this last one, I need to figure out the shaded region. I only know these regions. So if these arcs are congruent and they're central angles, those arcs are also equal to this central angle here. If those three are 60, 60, and 60, that adds up to 180. So the rest of my angles should be 360 minus the 3 of these, which is 180. So 360 minus 180, which gives me 180. So these are also add up to 180. So the shaded region here is 180 out of 360 times pi r squared, which is pi. The radius is PC, which is 12 squared. Well, this is a nice one that reduces, so go ahead and reduce it. 180 out of 360 is 1/2. So they're both divisible by 180. 12 squared is 144 times pi. So you get 144 pi for your numerator when you multiply straight across. 2 times 1 is 2. Is 144 divisible by 2? Yes, it is. So I'm going to reduce that again to 72 pi. Nothing left in my denominator. You can write it as a 1, but we're not going to write it. So at centimeters squared. Please check the front page of your packet to know which questions you're doing on the homework. It will also be written on the board.